Hi everyone, welcome to this month's webinar. This is going to be about BDD, behavior-driven development. If you ever wondered what does BDD stands for, I think you can leave right now. But wait, there's more. I'm going to talk about this. I'm going to talk about the mindset behind BDD, the history about it, what successful implementation looks like. I'm going to show you an example BDD code, the BDDs, as somebody I heard call them. So we talk about Cucumber and stuff like that. And at the end, I'm going to talk about BDD and TDD because we can't get enough acronyms in this family. So that's it. The reason I decided to do this webinar on BDD is that a couple of clients, different clients that I work with, turn out looking at BDD from different angles, and I thought, well, that's obviously a statistical majority, so we'll do something about BDD. Sort of a baseline, but I'm going to take at the end what you can take this. So welcome. I'm Gil, the one with the coffee here, and I'm a trainer and a consultant, and I work with teams who want to make software better. That includes developers, testers, and other people we are going to discuss today as well. They're called product or business people. And this tidbits that we're going to talk about today is a very short sample of full workshops that I do, both for introductory BDD and something a lot more in depth. So if you're interested in what you're going to see today and think about how can this fit my organization, ask me and I will hopefully have some answers for you and maybe even be able to help. So like I said, there's a course for that, a lot more deeper than what we're going to talk about today, but it is full of memes as well. So BDD, what is it? I invite you to go into, step into my time machine. We're going to go back in time for something like more than 20 years, and even a bit more than that. So you probably heard about TDD, test-driven development. This brings us back even further than that to 97. 97, JUnit came out. This is mostly the first test framework, although it wasn't really, well, a few before that, but this one actually caught on and people started writing tests, and the person who created JUnit, Kent Beck, also had a weird idea that he's going to write the tests before the code, and let's see what happens. Actually, was very successful. That was TDD, test-driven development, but it was developer thing. And I'll talk about why it's a developer thing at the end. So developers wrote the test, developers wrote the code. Jump forward for 4 years and a bit more than that. We're talking about 2001, the Agile Manifesto comes out. And if we go back to actually what the guys who wrote the Agile Manifesto, including Kent Beck, thought about was trying to solve something about bridging the gap between developers and business people. What kind of gap is it? Well, first of all, they didn't collaborate, didn't talk to each other, which was a problem by itself. But after the Agile Manifesto and the people who went into the Utah and had some ski events and the Agile Manifesto, they thought about, well, how can we bring these people together, especially the people who want to be together? And now we're jumping a few years later, and up until now, well, they started to talk. They have like big visible boards and post-it notes, whatever, and still have documents. So if you think about it, like if you haven't tried any BDD tool like Cucumber or something like that, you have documents. It doesn't matter where the documents are, if there's a Word documents or in Google Drive or Confluence or post-its on the wall. You have this, and you have like other documents like design documents and architecture documents, which developers write, and test plans. Like all these things are like spread around. And there's a problem with that because Agile was kind of trying to solve the problem of waterfall, like passing around the package of here, developers, take the requirements, go, we don't want to talk to you anymore. And same with the testers. Here's go make a test plan. We don't want to talk with you anymore either. So how can we make people talk to each other, review what they're doing, and work together all the time? And this guy in the UK, Dan North, Dan Terhorst North, you can look him up, still doing marvelous talks. He said, well, I have an idea. And the idea became a tool called JBehave. Now, behavior-driven development is called behavior-driven development and not test-driven development because he said, well, you know what? Business people don't talk to developers because they don't speak developish. And they can't read code, they can't redesign document as a general rule. But what if they could? What if they didn't have to? And the developers actually they do speak business-ish if they actually push them around enough. Let's try and like instead of bridging the languages and trying to do a translation, let's put something in the middle that will actually translate this thing. And JBehave was that. And later there were other tools. But BDD, this is what I want you to remember from this slide, except from Leslie Nielsen, is that it's an idea of how to bring collaboration into teams. It's not a tool or a set of tools, which leads us, of course, to tools. Because today, when people talk about BDD, and immediately it goes to tools like Cucumber, JBehave is still there. Funnily enough, in the last, we're doing this in January 25, JBehave. That the first tool was JBehave, and it's still there. But most of what you'll find today is Cucumber, the Cucumber family. We're doing this in January 25, which by coincidence, which I didn't plan, and it's not my fault, the Cucumber family comes or has all kinds of cousins in different languages. So you'll find this in Java, which I'm going to show you today, and JavaScript and Python and so on. And it has a cousin in the C# world. It had a cousin in the C# world called SpecFlow, which Tricentis bought a few years ago and killed last month. So currently, if you're looking for something in the C# world, there's a tool called Wreck and Roll, which is a fine name, and it rose from the ashes of SpecFlow, and people working on it are people who worked on the original SpecFlow. It's still considered part of the Cucumber family, and you'll find anything in any technology that you might want to use. The cool thing here is that, like I said, the idea is that product will write these kind of specs instead of tests. And the specs will run like tests. So in the end, what do I mean by the end? The product will write the specs, and then the developers will fill in the gaps. So by the end, the spec will run like a test and pass. And this is how everyone will know that the feature works. Genius. It's like testing, but seeing it with your own eyes. And I'm talking about the product here. Developers have this regularly if they write tests. Testers, the same if they have automation, or even if they're doing manual testing, they see it with their eyes that things are working. Product can now see it too in an automated fashion. There's a couple more things with that, like a single source of truth, like talk about that as well. But again, it's collaboration, and tools help us do it. These are regular test frameworks. We're talking about, it may look different, but it has the same properties as you have in test frameworks, and you'll see you can run it, you can debug tests or specs. The result of these things are regular test framework output, the JUnit XML. If you know this, you can run these things in CI and get results and failed builds completely the same as regular automated tests. So how does it work? I'm going to use the Cucumber example because we're veg friendly today. You have feature files in language which is sort of English-like, called gherkin. Yes, everything's cucumber flavored. And this is what the product writes. This is a text file, really. It's called a feature file. And behind the scenes, what developers write is in Cucumber language called step definition. They write steps. And Cucumber, the engine behind it, translates or kind of matches the lines in the text to the lines of code that need to be run, which usually run the product. And the product, I put it like in a very nice cloud here. It can be anything. It could be like, you'll see examples like regular unit test code. So it runs a unit like a class, or it can run an API or a set of APIs, or it can run Selenium or Playwright, like the examples I'm going to show you. While the script may be agnostic to what it's running. So that's the architecture. Let's see a demo. I prepared one already here. IntelliJ. Let's see what we are seeing here. For everything, just close everything. And you're seeing the first feature file. You see, this is a Java version of Cucumber, so it's kind of Java-ish. You'll see that the feature files are here. I have in IntelliJ a plugin for Cucumber, and you have something like that for everything that you're going to use, like PyCharm or VS Code. You have everything to do. And the extension basically is giving me the highlighting of the keywords here: feature, scenario, given, when, then, and I can run this. I'll run it in a second, so you'll see that it fails. And also the squiggly line here that you see here is part of the problem. So let's run this like a regular test. And you see everything you see here looks like a regular test. So you see Cucumber and then Cucumber calculator setup, which is here, which I'm going to tell you in details what I'm going to do here. And this thing here is the scenario. So a feature can have multiple scenarios, and scenarios have steps with given, then, and every step here has some kind of result. Well, obviously it doesn't work. What does it say? Well, step undefined. So it identifies something like a step here. A calculator was just turned on, and it doesn't have anything matching. So it even tells me, hey, copy that into your source file, and then you'll have a given annotation for a string called the calculator was just turned on, which matches this thing. And I'm going to run it for you. And you won't have any yellow squiggly lines anymore. And that's it, basically. That's the idea. So let's talk about the example here. I'm talking about my famous calculator example, which has basically it turns on. It has two methods like press and get display, which shows what it's doing there. And I'm going to kind of go through different examples here. And this is the first example, which doesn't do anything because nothing is in there. One sort of thing that I have to say for this demonstration is that I'm going to show you examples, and you see that the things that the text that I'm using different words every time, which is something that in the real world you will not have. The reason is that Cucumber is kind of very sensitive to ambiguity. So it has to be the same pattern that it's using to match the steps. And for that, I have to use different steps in my demo. But in the real world, you'll have one thing for a calculator that was just turned on. So this is just for you to know why words are changing on the screen. So let's take this into something that is more interesting with a bit of implementation. So this is going to be the same thing. On start, the display should show 0. Calculator was just turned on. It shows 0. You see no squiggly lines. Why? Because if I run it, it actually runs. You see it even passes. What is the code that is behind this? It's part of my test code. And I have a step definition file with a class here that basically what it does is on the calculator was just turned on, I'm creating the calculator, creating the class. And then you see that in my spec, I have only given and then, so I don't need a when. And it makes sense in this scenario because I'm just given the calculator was just turned on, it shows 0. There was no operation here. So when doesn't play here anymore. Don't need it. I have a given, creating the calculator, and I have a then, it shows 0. and I'm asserting that the display is 0. How does it work? Well, prepare to be dazzled. Let's look at the calculator here. I know, magic. But if you know a bit about TDD, you know that when you're doing this, like you add just the implementation that you need in order to pass the test. Same principle here. So this is why this is passing. But usually you don't write it like this. You will write it like this. So this time it's not like it shows 0, and because next time it will show 1, and then after that it will show 21. You probably want to make this more of a parameter. And this is how you do this. Only this is a bit different than the then that we had here. So if you look here, this is the second one. And this one, this is how you send in an argument in there. So it matches the pattern, says, this comes with a quote. That means it's a string that I'm going to put it here. And then I'm going to make the assertion according to what I actually got. And you can parameterize a lot of things like strings and numbers and whatever, even objects. You can serialize them into different things. So it makes the translation even more complex, but also simple after you're doing it a couple of times, because now they kind of use objects from the application to pass these things. But you can read a lot more of this about parameterization in the documentation of Cucumber. Okay, that's cool. Let's look at a bit more complex examples. This is where I'm starting to write scenarios for these things. So calculator pressing and display, and when pressing 1, I show 1. You see that behind the scenario there is no step definition, because the scenario is something like a container for steps. And this is where I'm using a give and when then. I can use and end translates to whatever was before it. So it can be for and for the given, and for the when, and for the then. And Cucumber is smart enough to know which method to, or which step to actually run. So here it will run press again because it's the when here. And that's very cool. So let's look at the step definitions for those. And you see I only have for all 3 scenarios the same steps. And this is the idea behind it. I'm going to be reusing, using and reusing steps, but steps that have the same structure. I'm going to use or reuse the same steps. That's the idea behind it. So cool, nice. And you're thinking, well, this is a very sophisticated calculator. I'm going to have a lot of these examples, right? Should I actually duplicate this? We don't like duplication in our code or in our specs. You're right. People have actually thought about this. So what you see here is if you worked with some kind of data-driven tests or a parameterized test, which is completely the same, but have this different name in different places. All test frameworks have those. Cucumber has this too. So on it, it's called examples. And you see that this time it's not a scenario, it's a scenario outline, because it tells Cucumber, I'm going to run this multiple tables. Steps are the same, given, when, then, but I'm doing this here. So I'm giving what it's called examples in Cucumber, and I built this very nice table with delimiters. And each one of those is a case. Let me show you. And just like any test, you get the report here of example number 1, example number 2, given the steps, what I sent in, what is sent here, and the same here, and so on. What is stands, let me hide this. So what stands behind this? What are the step definitions? Easy. We have the calculator created again. This is a bit interesting though. Let's look at this. So I'm gonna kind of do a bit of a cheat here. Well, it's not a cheat, the design decision. And that is, you see that here, I'm going, well, let's run this again. I want to show you again. What's being sent is the whole string here. Okay, so for example, in here, I'm sending 12 and it displays 12. Yeah, but this is not my design, right? My calculator has a press for a single key. So I need to translate this 12 into press 1 and then press 2. So it's not a cheat, it's a translation method. For people who are not fluent in Java, this is basically take the sequence that you got, the 12, split it into 1 and 2, and call press with each one. Press 1, press 2. Java streams, and it's interesting syntax. But this is what it does. So it's not a cheat. The test, as the product will write it, is this. But when I'm operating the machine, when I'm operating the calculator, I'm going to press 1, press 2. What I'm seeing here without any logging is what this says. It's not what this does. It's interesting. Okay, great. We've seen these examples. Let's move forward with another one. So, like I said, if you're looking at this saying, wow, this looks a lot like unit test, right? Like, it's for developers. Like I said, doesn't have to be. Same feature, okay? Only with something that calls an API. Now, how does it look? Close other tabs. Well, it depends on your wording, really. Like, for example, I don't have calculator is on because it runs on the server. So I may find other words to use to describe what I'm doing. So maybe calculator is ready. And then I know it's an API. I'm going to send press because I'm going to send an API request to do that. So going to press 1, going to press 2, then it returns 12. How does it look like? So again, class with a string only. What is the meaning of calculator is ready? Well, maybe I need to ping it. So I'm using here a library called Rest Assured for making API calls, REST API calls. And funnily enough, it also speaks with given, when, and then. And what I'm doing here is I'm sending a GET request to the URL or ping, and I'm checking that it returned a 200 because this is my interpretation as a developer of what calculator is ready. And then I can press a key, like press 1, press 2, and then I'm going to do a post with the URL of press and the key as a request parameter. Again, this is the design I chose of the APIs, depending on what the spec is, if there is a spec for that, or I decide what the API looks like. And again, I'm checking that it returned 200, and this is like an assert. If it doesn't return a 200, the step will fail. Finally, it returns something. I need to go to the calculator/display endpoint, check that I got a 200, and check that the JSON has a field called result, and it equals to my expected thing. And this explains how this will run. But here's the thing. I decide as the developer what the code in the steps look like, right? Because I write the endpoints, I code it, and I know how to get there. So let me write it differently. So this is basically the same script, only it runs a different way. So let's look at this. How does it run? Oh, okay, so same URL, but at the given, I'm not doing anything. If you think about it, it's a server, right? That I ping it and then in another step do something in it, it doesn't make sense to, no, that doesn't make sense. It makes sense, but it's very hopeful that the server will actually be there. But it may not, because it could be like go away or drop down between REST API calls. So I'd rather do all the API calls together. Why? I'm doing the interpretation. So another calculator is ready. I'm not doing anything. Send press. I'm not sending anything, but I'm just storing what I was sent to press. And this time on the display, I'm doing everything. Not much sense in calling ping because I'm just going to call the API. If it doesn't answer, it will fail. Same information. So no need to do that. Here I'm just sending post with the request by splitting the sequence 12 into 1 and 2. So two separate API calls and both checking that they got 200. And after that, I'm going to do the get for the display and check that the 200 is returning the right thing. Okay, what's the difference between these two? So when everything's working, everything will work. So let me go back to my API thing. Both of them will pass. But the thing is that if the server doesn't answer for some answer on the first one, it will fail here. But on the second one, it will fail here. Now, because I'm doing the translation or giving it my interpretation, depending on who you ask and what answer you expect to have, the interpretation really is down to the implementer, unless you work together. Both the product people and the developers and the testers sit on this and explain exactly what they expect to see. Maybe they expect version 1, maybe they expect version 2. Again, collaboration is what the tool is there to facilitate. It's not just to run code. This is like an API example. I can do this with the web as well. So I prepared something for you, something very nice, looks like this. Looks even better like this. So HTML that runs the calculator like 7, something like that. Let's close it. I want to operate a page. How do I do this? I do it with Playwright, same idea. So I'm going to show you the feature. Notice that, hold on. I want the UI and then nothing else. Yeah. So see this annotation browser, but other than that, everything is the same way. I'm just doing like a calculation, 1 + 2 = 3. But I need to give the interpretation. So what is this? Like any test framework, you can annotate stuff, and this is like annotating the test suite or the test class, whatever you're used to. And this helps me do something. For example, in my tests, I need to run something before everything in the scenario, and then something after. Because I'm going to use Playwright or Selenium, it doesn't matter. I can't kill my session between steps and create everything because I'm continuing with the same driver. So I need to raise everything before a scenario, after a scenario. Unless I need to tell it, well, run is only on browser-related thing, not on everything that you've seen until now. So what does it look like? So we have something, calculate step definition, fields, blah, blah, blah. And I have before, which is before scenario, after scenario, before step, after step. You have all kinds of facilities to do this. And you can specify before what kind of features or tags or different things that you're going to do. In my case, I'm initializing Playwright and browser and page before the scenario and cleaning everything up after the scenario. And then my test looks like this. I'm navigating on pages loaded. On press button, I'm finding the locator with the name that I sent, 1, 2, plus. And I'm clicking it. And then the result should be X. I'm going to find the text box that the result is in there, and then I'm going to make sure that it has the value. This is like Playwright syntax. And that's cool. But you're looking at this, you're probably thinking, well, it's not going to be like this easy, right? Like we have like major applications, complex scenarios, going to navigate between pages. these things are starting to look more and more like the API example from before when you started stacking things up. And that's true because code is code. It will not just go away. We need to manage that. So one of the ways you can do that is write code that is manageable, maintainable, readable. So the same thing here with a bit of different implementation. So I'm going to create a page object model, and you've seen me probably talking about this in Playwright and other videos that I did. So I have a calculator page object model, which has all the Playwright things. Create the Playwright, the driver, the page, closes everything's down. Then it has a navigate method that passing the server, so I can play with different servers. And then I do navigate because it knows the path and it knows how to do press, finding the button and clicking it. It knows how to get result. And then my step definition uses that. And it creates the POM initializer navigates, press, called press thing, and get display, get the results, do the assertion, and close things up. So a couple of things to talk about in terms of what we get, what we don't get from using these kind of things. So first of all, I mentioned that before, you have executable specs, you can run them in the CI. That's cool. It's different than any manual test, but it's exactly like any other test. You can run them, run them in different suites, in different steps of a pipeline. Regular automated tests in that thing. But the cool thing is now you can put this as part of a repo. So think about this, let's say our code and our automation code sits in one repo. It's not always like that, but for simplicity, let's say that this is. If I want to, let's say, run a test plan that I prepared on an older version, I need to go back in time. I can run automated tests, I can run these specs, but I can't go back and do manually a test plan unless it's really step by step by step. Only this time, with the specs here, you can actually put the same label on them, and the code, the automation blocks, the tests, the specs, all get the same version. So you really can go back in time with everything in order to reproduce stuff, which is interesting and very valuable. Think about it. The code, you've seen it, it can get, and it will probably get very complex, and you need to manage that like an actual, basically it's an automation infrastructure. So you need to manage it like any infrastructure that you do. It's a coding project. You need to write the code according to different principles, which are good principles, like clean code and everything, testability, readability, maintainability. You need to do that. You don't run away from other things that will appear in regular tests. If the tests are fragile, this will be fragile as well. If it's slow, it will be slow. So you need to invest in stability in making these things run fast. And one other thing that you get by using Cucumber on any other tool is that you've actually added a layer of something that may create bugs by itself. So there might be bugs in Cucumber, there might be bugs in the translation. If you just write the test yourselves, kind of skip that, sort of. But there's another layer here that could complexify things, or make that more complex if you're actually using English. So you need to be aware that you're adding another layer of something that can go wrong here. Now, big question, does it work? Not at all. Well, it really depends on your implementation of, not implementation, your definition of what really works. So the question is what you're trying to achieve. If you're trying to achieve real BDD, the original BDD, like people talking to each other, the tool won't do that for you, right? It will help, but I've seen a few things that different kinds of implementations, of flavors of implementation, and you can decide whether it is a success or not, because a lot of you won't see a lot of these things in the wild, like out there, especially if I haven't seen too many organizations working like that with product actually writing the specs, not just writing, it's maintenance, right? Because if things change, somebody needs to go and change the specs, like changing a requirement document. I know how requirement document looks and update. So this actually needs to work, because otherwise the specs will continue to run with the former requirements. No, they're going to lie to us like unupdated tests. So I haven't seen this thing a while in a lot of companies. So what did I did see? I did see like teams working where the product didn't write the test, but the testers did. So the manual testers, not the automators, because they could actually write tests. So I saw people working like in a sprint. At the beginning of the sprint, the developers and testers would sit together. Testers would write a script in Gherkin, and they would talk with the developers and explain what they want to see running at the end. And the developers will go onto the side, write glue code or step definitions and the code of the features. And by the end of the sprint, you'll actually have a feature file running, the spec running and succeeding. So, and you do this like over and over again, like every sprint. So this thing I actually saw working, and it worked for that team as well, and the whole organization. You can see that it is a failure, maybe not a failure, depending on how you look at it, that if the developers are writing the specs, kind of misses the point of the original BDD, right? But this is what I've seen most. So people like writing the specs, which they probably don't need to, because developers, they can write tests by themselves. But they have a lot of tests running, and so this is the way they are writing non-developer tests. Like it's not like API tests, it's not like unit tests, but these are our system tests, and this is how we work, and sort of works for them. So I can't really say if it's a successful or a failure. It's not the original intention of what BDD was, and sometimes that's okay as well. Final thing I want to talk about is BDD and TDD, because acronyms are our life. So both BDD, behavior-driven development, and TDD, test-driven development, come from the DD family, which is driven design, something like that. And other people from this family are ATDD, automated test-driven development, which kind of may be similar to BDD or not. And domain-driven design, which doesn't have anything to do with test, more with architecture, but again, coming from the do something first family. So in TDD, BDD, we write the test or specs first before we write the code. So yes, same family, but and they work very well together. I did something which I'm going to show the example soon, but I want you to understand that if your developers are doing TDD, what they should see or expect to see, and that is in TDD, if you're doing it properly, which this is like a whole set of webinars on what proper TDD is. But if you do this, what you'll see is that you have tests passing like every few minutes. So, and I'm talking like not just a single test, like everything's green like every few minutes. And this is different in BDD, because these are like usually will be like system tests. So think about how much code you need to create for the spec or the test to pass. So that means that if TDD is, you'll have tests passing like every few minutes. With BDD, it's going to take hours, days, sometimes weeks, until a spec passes. And this is okay, because this is the cycle of things, circle of life. I did a project once, which I actually did these two things. So I had specs, and this was like a whole project of reading files, code files, understanding them, parsing them, understanding which things in the code are tests, ranking the tests, whole interesting story. But I had the specs written in the beginning, which kind of guide me to where I wanted to go. And I worked with TDD, and same pace of TDD, like a few minutes, something working, and I worked with TDD on different components and started integrating them. And it took weeks until the first spec actually passed. So this needs to be like the expectation, unless you're actually using spec code to write unit tests, but you probably won't do that. One of the benefits of having tests first, and that's true for BDD as well, is that, remember I showed you the calculator that returns 0 always. That's part of the way to do TDD. It's like write the code that works, that passes the test. One of the benefits of that is you write a lot less code. And a lot less code means a lot less bugs. You only write the code that passes a test. And that is true for BDD as well, because the BDD specs are really like guides, tell you like, this is what should work at the end. Write the code for that. And developers, when you guide them the right way, will walk the right way. So, and that means that they write less code, again, less bugs, and everything passes at the end. So that's cool. What's next? So if you want to take your first steps in BDD land, first of all, think about what you're trying to achieve. Because if there are organizations, not going to name names, that the product or business people will not participate in this game. They will not write the specs. They will maybe write them once and never look at them again. So decide further if this idea of BDD, the original idea, which was bridging the gap, doing the collaboration, will work in your company. People are willing to try this, because if they are, that's cool. There's going to be a lot of benefit from that. But some organizations are not built for that. They're not mature yet. They're a bunch of little children hitting each other. So if that's the case, stick to something else, like doing either different levels of automated suites or automation suites. The responsibility will be with the developers and the testers. But if people are willing to try this and see the benefit, then go this way. If the product people won't play, but the testers are willing to play, there is some benefit in that as well. So you need to look and try to see what is the flavor of implementation, not BDD, but the implementation that will work for you. If you're just a development team or automation team and you're looking for a tool which you're going to maintain yourself, I'm not sure if this is like going to be like using a tool like Cucumber will give you enough value. Again, the value is brought when people are not reading code, so they can participate in the discussions if over something that they can read, and everybody can read, because like it's written in vegetable doc. So you need to think about, well, what's in it for you. One thing I'd add is that if you want to see how it looks like, and this is something that is very cheap to do, you can write feature files from existing test plans that you have and see how they look like. So if you have the test plans, like think about how this will look like in terms of Gherkin file. And then you can show it to other people and say, does this make sense to you? And if you create these examples and people react well to that, then you can move forward with trying to automate this stuff. Maybe you can very easily. Maybe you'll find out that you can't. And wow, this is interesting. I can't automate this thing. Why can't I automate this thing? It's interesting. So these are the first steps. If your team is doing TDD, they probably won't be doing TDD, and most people don't. But if they're willing to do this, hey, cool. Do this together. And this is what I wanted to share with you today. If you have any questions, please write them in the chat box. I will try to answer them. Other than that, go to the site, everydayunittesting.com or testinghill.com. There's a blog there and a list with the courses and workshops that I do. Watch YouTube, because I do this videos weekly, so webinars go there, webinar recordings like this one, and other videos on all kinds of things with short videos, which you don't need to spend like an hour with me. I know this is very taxing. And otherwise, get in touch with me in whatever social network that you use, not TikTok, so not there yet. And let's see, our BDD gherkin cucumber actually used. So yes, they are used. There is usage, but it depends on the company and company culture and what they're trying to achieve. So like I said, the tools are there, you can use them. It depends of what a successful implementation you will see. And I saw this working. I told you the example of the organization, and unfortunately, like not too many. And they had their own definition of success. So what is successful? What works for you? What kind of things I can achieve? And they achieved like automated tests that the testers, non-technical testers, wrote. So, and it worked for them. So it depends on your definition of success, what can work. And it's not like, and compared to Selenium, so it's not like Selenium is a bit different because it's not a test framework, really. It's a driver. But if you compare it to Playwright, for example, which is a test framework, it's a different way to write tests. So the only major thing about it is the inclusion of non-technical people in it. So all the other things that you probably know, like test frameworks, like from JUnit to Playwright to whatever, it's developer oriented. It's for people who write code and read code and know how to automate stuff. So if you want to include other people who are not like that, the BDD way. So I hope I answered that. I want to thank you for spending this time with me, and I hope you'll join for other webinars as well, probably one every month going up. And you can check the YouTube version of this thing soon, and other webinars are already there. Thank you again for coming, and have a nice rest of weekday and so on. Bye-bye.